So what we're going to look at now are quartiles. And what quartiles are is they're just percentiles. So now there's special ones. So Q1 is the 25th percentile. We actually calculated this for the Verizon data in the video on percentiles. Q2 is the 50th percentile, and Q3 is the 75th percentile. So basically, you would find the location. You're going to use the same formula. L equals n times k over 100 to find the location of these values. So Q1 would be the value where 25% of the data is below that value. Q2 is 50% of the data is below this value. Q3 is 75% of the data, about 75% is below that value. And again, this could be a value that's in your data set, or it could be a value between two data values in your data set, depending on what L does. If L comes out to be a decimal number, we always push it up to the next whole number, and then that's the location of our data value that has that percentile of data below it. If L is a whole number, we find that location in our data, get that data value, take the next data value above it, and then average those two, and that value, below that value, will have that percentile of data below that value. So they're just special percentiles is what they are. And again, we use the same technique that we would use for finding any other percentile. So if you're going to compute Q1, the L value for Q1, again, it would be, say, n times 25 over 100. Q2, the L value is n times 50 over 100. And then for Q3, the L value is n times 75 over 100. And then you got to handle the L values appropriately. So there we go. So let's say we've computed these. We actually put these to some applications right away. And probably the most important one is what we call the IQR. And we'll use this later, but the inter-quartile range, or IQR. And what this is Q3, what other data value we found for Q3, minus the data value for Q1. It might not be a data value, it could just be a value. So this would be the value for the 75th percentile. I'll abbreviate percentile. And this would be the value, and it could be data, it could be an average of two data values for the 25th percentile. And then the difference is the interquartile range. And we use this when we're trying to figure out whether or not something is an outlier. Another use of this is the semi-interquartile range. And this one, we just take the quartile range, divide it by 2. That's it. Then we have what's called the mid-quartile. And what the mid quartile is, we take Q3, we add it to Q1 this time, and then divide by 2, we average it. All right. And then lastly in this section, they mention really percentiles again. It's called the 1090 percentile range. And instead of the, say, the interquartile range, where you took the value at the 75th quartile and subtracted from it the value at the 25th percentile. Here, we'll use the data value at the 90th percentile and subtract that, or again, maybe it's the value in between data values. The value at the 10% or the 10th percentile. I'll abbreviate percentile. Now, why do we want these? Well, what we do with them is we use them to come up with a summary of the data. And we were talking about earlier with histograms, it's a way of picturing the data. And this is another way of doing that. It's just kind of a slick way. And what we do is we call it the 5-number summary. And we just quickly represent the data using 5 numbers. The first number is the minimum data value. Whatever the smallest data value is. The next one is the first quartile. Now that could be a data value. It could be, say, some value that was the average of 2 data values. Again, it depends what L did. Next, second quartile. Then the third quartile. And then finally, the max data value. So again, the minimum data value, the max data value, those are just going to be there, no problem. Here, the quartiles, it depends what happens with L. These could be data values. They could be the average of a couple data values. So again, it depends on L. But this is a quick way of summarizing data. Now, as an example, again, let's look at the Verizon data. Now, for this one, the minimum data value was 0.8. And then we calculated Q1. That was the 25th percentile. Q1 was, let's see here, 7.9. And then let's say we went ahead and calculated Q2. If we went ahead and did the same thing for Q2, use that same formula we used to calculate the 25th percentile, except now we're using the 50th percentile. So K in that L formula is going to be 50 instead of 25. What we would get once we've adjusted everything is 13.9. And taking a look at the data, there is no 13.9 in our data set. So that probably means that this was the average of 13.7 and 14.1. So when you calculated the L value for the 50th percentile, what you got was a whole number. Looks like you probably got 1, 2, 3, 4, 5. You get 15. L turned out to be 15, and then you had to go one more to 16. Let's double check that. Let's make sure. Oh, I'm sorry, 25. It's 25. 13.7 is at 25. So they probably got 25, and then you have to go one more to 26. And sure enough, that's what you're going to get here is 25. So you take the data value at position 25, which is 13.7. Also take the data value at 26, L plus 1, and that was 14.1. Average 13.7 with 14.1, you get 13.9. So that's your 50th percentile. And then Q3, the 75th percentile, again, you would do the same thing, except now K is 75. You get 21.5. And then for the max, we get 77.8. So these are the 5 numbers in the 5-number summary. And this is just a way of quickly describing your data. Now, we said earlier that a picture is worth 1,000 words. And that's still going to be true here. We're going to turn this into a picture. And the way we do that is with what is called a box plot or a box and whiskers plot. And the way you put this together is this. Let's draw a line. And we have our smallest value, our minimum, and then we have our max. And again, I'm using that data set for the Verizon data speeds. So I've got my minimum value, I've got my maximum value. Now I'm going to insert my quartiles. And that's where the box comes in. And let's see here. Let me take a look, make sure there's some accuracy to my picture. So the 25th percentile was 7.9. The 50th percentile was a value that wasn't in our data. It was 13.9. And then the 75th percentile is 21.5. Now you might be looking at this and say, okay, wait a minute. This is kind of halfway. It's not 75%. And here's the thing. This is talking about the number of data points. So at this point here, the number of data points, 75% of them are below 21.5. And so that means there aren't that many. There's only 25% are above. So this is actually skewed. There's not much data on this end, but a lot more data on this end. That's what this is saying. So there's a whole bunch of data here that's pretty dense, and then it gets very sparse out here on the right. So one thing we can notice with this, there's skewness. We can see skewness in a box plot or box and whiskers plot. And this reflects histograms and stem plots. Because remember, with stem plots and histograms, we could also see skewness. Now, there's one thing about this that it doesn't do. It doesn't show distributions. I'm going to abbreviate distributions. It gives us an idea of how the data is spread out, but we don't have a very clear sense at all about frequency here. So, but we do get some idea of how the data is spread out. And then what the text says here, it makes a little note. These are great for comparing different data sets. And there you go. So those are your quartiles. That's your box and whiskers plot. If you have any questions, let me know.